Hi, this is NV Fitton with recordings for Chapter 2.1 on complex numbers for Math 163. Recall from the very first day of class that we talked about sets of numbers, important sets of numbers, such as the natural numbers or counting numbers, 1, 2, 3, 4, etc., which are a subset of the integers, which include 0, -1, -2, -3, and so on, which are a subset of the rational numbers. That Q there is for a quotient, as in ratio. Those include fractions and repeating decimals, all of which can be converted into fractions. And the rational numbers, if you add to them such irrational numbers as pi and e and any non-repeating decimal, whether it's positive or negative, then you get all the numbers on the real number line. In other words, the real numbers. And we have referred to that set many times when we talk about a number being any value in the real numbers. For example, when we're talking about domains. So, are the real numbers all the numbers that there are? Have we got any numbers that are actually unreal? Well, let's be polite and call them imaginary numbers rather than unreal numbers. Imagine a world in which even negative numbers have square roots. Not just 0 and positive numbers, but negative numbers too. For example, -1, a square root of -1, which we would never ever do in the real numbers. That makes us shudder with fear and horror. However, if we can imagine a square root of -1, then we can imagine a square root of any other negative number, such as 16. If we have a square root of a number, -16, well, we could factor it using the rules of square roots into the square root of -1 and the square root of 16, which of course is a real number, and then just take that real number times our original square root of -1, and in short, for any negative number, we would be able to find a square root by factoring out that square root of -1. Now, it kind of gives me hives to write the square root of -1, so instead I'm going to define it this way. I'm going to say that I, for imagination, squared is -1. Ooh, there it is. Okay, so I squared is -1. Just plain I is I, that imaginary number. I to the 0th power, like anything else to the 0th power, is 1. I to the 3rd power, well, that's got to be I squared times I, which means that it is -1 times I, or -I. I to the 4th would be I squared squared, which would be -1 squared, which would be 1. So you can see that we have gone in a circle, and we can carry on with that and take this imaginary unit, that's what I is called formally, to the 5th power, to the 6th power, whatever we please. Okay, so we all know that the real numbers are contained in a set called complex numbers, and that we write complex numbers in this way. We have two coefficients that are real numbers, and one of these coefficients stands by itself as a real number, and the other one is a coefficient of the imaginary unit. Okay, so here's our standard form for a complex number. It has a real component and an imaginary component. So 5 plus 2 times I is a complex number. That coefficient could be negative as well. That would give us 5 minus 2i in this case, possibly. The imaginary unit can have a 1 as its coefficient, so that gives us something like 3 plus I. And let us not forget that 3, a natural number, since it's one of the real numbers, is also an element of the complex numbers. Okay, that's it for our introduction.